All right, let's begin. So, today we will be covering organic chemistry. So, first of all, have you all ever heard the word organic chemistry before? Do you know what does organic mean? Any idea about this? The word organic. Something is what? No problem if you're wrong. Just whatever comes to your mind, let me know. If I say that I like to eat things which are organic, what would that mean? The original place, or like which comes naturally, which is not man-made. Yeah, exactly, very good. So organic means natural. Okay, so remember this term, that the word organic simply means natural. If I say something is organic, it is natural. It is coming from the nature. It is being provided to me by the nature. I am not preparing it somewhere in the lab. All right, if I am preparing something in the lab, that means it is man-made. Got it? Okay. So, in this chapter, we will be studying about all these structures and compounds which are provided to us by the nature. Now, remember this thing. Uh, so, have a look over here. The word has been linked to the ideas related to the natural world. Organic molecules were once believed to have distinctive chemical properties, making them unique to living organisms. In simple words, I'll make this chapter very simple and easy for you guys. I won't make it very lengthy for you. So in simple words, all you need to remember whenever you hear the word organic is only two elements should ring bells in your mind whenever you hear the word organic. These are the main two components that make up all the organic compounds out there in our world, which are carbon and hydrogen. So, what how do we define organic materials? So, organic molecules are basically, in other words, hydrocarbons. Hydrocarbons. Now, what does this mean? This means that they are made up of carbons and hydrogen, in which carbons chain with each other and form bonds along with hydrogens, and there are many functional groups that change the structure and the properties of these organic molecules uh, accordingly. So the basic main groups that we will be studying in IGCSE are alkanes, alkenes, and alcohols. Otherwise, there are like lots, lots of other functional groups. Some are alkynes, ketones, aldehydes, esters, and many more. We won't be discussing that. That is part of our A levels syllabus. So we will be studying about these three molecules. These three are organic compounds. They are also hydrocarbons. What does it mean? Every organic compound must have carbon and hydrogen in it. Got it? Let's talk about alkanes. Remember this. Alkanes form single bonds between carbon atoms. Alkenes, on the other hand, they form a double bond between the carbon atoms. Okay, and then alcohols, we get hydroxide OH attached with our any functional group over here. I will be discussing this later. So this is a basic structure of alkanes, alkenes and alcohols that we'll be studying. So before that, let's first quickly study about carbon, because carbon plays a very important role in this whole organic chemistry. So see this. Carbon is unique in the variety of molecules it can form. The chemistry of carbon containing compounds is known as organic chemistry, and the three special features of this, okay, one more thing, all the bonds that you will come across in organic chemistry, they all will be covalent bonds. Why covalent bonds? Covalent bonds. Why covalent bonds? Because all these bonds are made between non-metals. Okay, and you all already know that ionic bonds are made between metals and non-metals. All right. So in organic chemistry, what are organic molecules? What type of bonding do all these organic molecules have? They make covalent bonds. They do not make ionic bonds. So when we are talking about carbon, these are the three main points that you need to remember and properly memorize. It's very easy. Carbon atoms can join to each other to form long chains. Atoms of other elements can then attach to the chain. Let's see what do they mean. I'll make a drawing over here to represent it. When they say long chains of carbon, they mean something like this. Carbon, then a bond with another carbon, and another carbon, and another carbon, and another carbon. Now, before I make other bonds with this whole chain of carbon, my question to you guys is, how many bonds can a single carbon make? What is the valency of carbon? What is how many bonds can this carbon make? Do you all know the valency of carbon? In which group is it? If you all don't remember it, go through the periodic table quickly and tell me how many bonds can carbon make. Like, very good, it is 4. So that means it can make 4 bonds. Yes, it cannot make more than 4 bonds or less than 4 bonds. So for the carbon to become stable, the carbon must make 4 bonds. It must complete these 4 empty spaces to become stable. So have a look over here. If I'm like, I'll just talk about alkanes with you guys. So alkanes is one of the functional groups. It is one type of organic compound. So alkanes here, they have a chemical formula. A general formula for these alkanes is CnH2n plus 2, where N over here is the number of carbons. For example, let's say I want to make an alkane which has around 1, 2, 3, 4, 5 carbons. Then what would I do? So I just told you that alkanes make single carbon-carbon bonds. So if we are talking about 5 carbons, 5 carbons making a bond and forming an alkane, what would that mean? So we have to make a first we'll make a chain of 5 carbons over here like this, 1, 2, 3, 4, 5, and that's it. Now we just make other bonds and we attach hydrogen with it. So alkanes is basically hydrocarbons. And if we make 5 bonds of carbon, let's set up the hydrogens now. So see over here, this is one bond, this is the second, third, fourth. One, two bonds already over here for this carbon. This is the second bond, this is the third bond, and this is the fourth bond. In the same way, two bonds over here, third bond, fourth bond, third bond, fourth bond, third bond, second bond, third bond, fourth bond. Is this part clear? All right. Okay. So this part, these are the empty spaces. These will be filled up by hydrogen. So this is how I set up all the hydrogens. Is there any carbon left in which it is not making 4 bonds in this whole structure? Are all the carbons valencies fulfilled? Have a look and let me know quickly. Yes. Okay. Is this clear to everyone? Okay. So if you come across any compound in your exam paper which looks like this, in which all the carbons, this whole carbon chain that you see over here, this whole carbon chain is making single bonds with each other, the first thing that should click in your minds is that it is an alkane. Got it, guys? Okay. Now I'll teach you, without making the structure, how would you know how many hydrogens will be there for any alkane, depending on the number of carbons. Like I said earlier, the formula for alkanes is CnH2n plus 2. Let's see how do we get the number of hydrogens. Let's say that this is an alkane for 5 carbons. Without making this whole structure, how would I know how many hydrogens will be there in this alkane which has a carbon-carbon chain of 5 carbons? So C, in place of N, I'm going to write 5 because we have 5 carbon chain. So in place of N, I'm writing 5. Then H, 2. And again N over here. So I write 5 again plus 2. So C5, H. 2 5s are 10. 10 plus 2 is what? 12. So if we have 5 carbon chains, single bond chains, then how many hydrogens will be there if we are making an alkane? How many? 12. Okay, let's count. Do we have 12 carbons over 12 hydrogens over here? Right? 1, 2, 3, 4, 5, and then 5 below, that makes 10, 11, and 12. Got it? Great. In the same way, let's say now I have another carbon chain which is made up by 2 carbons. This is how the chain should look like. Yes or no? Okay. And in these empty spaces, I just fill it up with the hydrogen. So according to the formula that we just studied, if I do not make the structure and I'm asked that how many hydrogens would be there if we have only 2 carbon chain, let's see how it would look like. Carbon, in place of N, I'm going to write the number of carbons, that is 2, H, 2N plus 2. So C2, H, 2 2s are 4, 4 plus 2 is 6. So this over here will have 6 hydrogens. If I have 2 carbons, this alkane is going to have, if I have 2 carbons, this alkane will have 6 hydrogens. Is this part clear? Okay. Now let's talk about the naming. We have to name all of them. What should I name this? It takes a lot of time if I say make 2 carbon chains and it should be an alkane. Instead of this, I need just one word, a name for it, that when I say that name, you must know that what am I asking for you guys to make. So let's learn that now. How would we name them? I already wrote it somewhere. 1 minute, let me check here. This part. Have a look at this now, guys. For the number of carbons, we are going to go through some prefixes. Like in physics, we studied about prefixes, if you'll remember, like milli, centi, micro, nano, pico, kilo, right? In the same way, we have these prefixes for the number of carbons that you all need to properly memorize. When I am talking about one carbon, the single carbon, which does not have any kind of chain, I'm talking about making alkanes right now. So when I'm talking about just one carbon alkane, so the name that you must remember for it is meth. One carbon means meth. 2 carbons mean eth. 3 means prop. 4 means bute. 5 means pent. 6 means hex. 7 means hep. 8 means oct. And 9 means non. Let's see how would they look like. If I have just one carbon, yeah, this is just the first part of the name. I'm going to teach you how do we like write down the whole name. Okay, I'm teaching it right now. So let's talk about this one carbon. So one carbon means it's going to have 4 hydrogen bonds connected with it, like this, right? So as I told you all, one carbon means meth. Now, as you can see, all these are single bonds, and the formula over here is CH4. I'll write it here. CH4, which represents that it is an alkane. So to tell that whether the organic compound belongs to the family of alkane or any other functional group, we always write the name of the functional group at the end. So in this case, if as this is an alkane, so I'm going to write ane at the end. So the whole name for this compound is going to become methane. Do you guys get this? Yes, you will always use the word ane as the functional group at the end only for alkanes. For alkenes, we will use another word that is ene. We put ene at the end. Okay? So for now, properly memorize this part. Great, great. So we were talking about one carbon bond, one carbon alkane. It will be called methane. What will we call an alkane which has 2 carbons? We will call it ethane. What do we call a carbon which has, what do we call an alkane which has 3 carbons? We will call it propane. The same way, 4 carbons alkane will be known as butane, and then pentane. After this, hexane, then heptane. Then what do we have? Octane. And in the very end, what do we have here? Nonane. Is it easy? Any questions till here? So, according to all these names, you will be making structures. You will be making the chemical structure, the chemical formulas as well. For example, methane will be CH4, ethane will be C2, and then H2N plus 1. 2 2s are 4 plus 2. Sorry, CnH2n plus 2. So 2 2s are 4 plus 2, that is 6. For propane, C3. What will it be? 2 3s are 6 plus 2, 8. Do you understand how I'm making all these uh, chemical formulas? Okay. Yes, I'm just adding, I'm putting H2n plus 2. This is what I'm using over here. Okay, in place of n, I'm just writing the number of carbon, I'm multiplying it by 2, and then I'm adding it with 2 to get the number of hydrogens that we will get. Yeah, the homologous series, yes. So HCnH2n plus 2. What will be for heptane? Heptane means how many carbons? 7 carbons. So I'm going to write C7H2 into 7 plus 2. Very good. 16. 2 sevens are 14 plus 2. 16. So heptane will have a total number of 16 hydrogens. Is it all clear? Okay, great. Now let's talk about two terminologies. One is known as saturated hydrocarbons and the other is known as unsaturated hydrocarbons. Now do not forget this, which I'm telling you. Saturated hydrocarbons, they are hydrocarbons in which we have carbon-carbon single bonds. And in unsaturated hydrocarbons, we have at least one, either we have a carbon-carbon double bond or we have carbon-carbon triple bonds. Do you understand what I just said? Yeah, that's what I'm telling. This is the difference. See over here. Saturated hydrocarbons will have single carbon-carbon bonds like alkanes. Alkanes are saturated hydrocarbons. Saturated compounds and unsaturated ones are also different. Saturated, like for example, if I talk about a saturated solution, what was the saturated solution? Do you all remember? A solution which cannot mix up any more other molecules. Exactly. And unsaturated means that it still has some space left for mixing. Okay? So, if they ask you to write down an example of saturated hydrocarbons, what will you write? You will write, you will list down the alkanes for them. Got it? And when they ask you to give an example of unsaturated hydrocarbons, you will list down these as your example. Alkenes and alkynes. Alkynes make triple bonds, whereas over here alkenes make double bonds between carbon carbon. You all won't be studying about alkynes, it is not part of the syllabus, so don't worry about this. You need to focus on these two things, alkanes and alkenes. Is this part clear, guys? Okay, now I'll be quick with you in telling you what are alkenes. I'll make it over here only for you. The whole logic is the same. The only difference is the difference of the general formula and the structure. I'll show you how. Let's see, for example, now I'm gonna write down about alkenes. Very good. Yes, it is CnH2n. The general formula for alkenes is CnH2n, whereas the general formula for alkanes was what? CnH2n plus 2. So let's see. Now, alkenes start with two carbons because alkenes must have a carbon-carbon double bond to represent them as alkenes, as that functional group. If we do not have two double bonds, two double bond of carbons, that means it is not an alkene. So therefore, we cannot have a methene. A methene must have what? One carbon, right? And I just told you that an alkene should have what? Double bond with another carbon. So meth means one carbon. How can one single carbon make a double bond with another carbon? It cannot, right? Therefore, we do not have methene. So alkenes start from ethene. Do you get this? Yes or no? Okay. So ethene. It starts from two carbon double bonds. So have a look here now. These are two carbons. They have already made their two double bonds over here. So this carbon has two bonds already made. How many bonds are left for this carbon on the left? Only two bonds. How many bonds are left for this carbon on the right? Only two bonds. Let's count. One, two, three, four. The same way for the right one. One, two, three, four. Do you get this? And what do we attach over here? We attach our hydrogens on these places here like this. So what do we call this? You say it is C2H4, and this is called ethene. Do you get this? Great. In the same way, let's give me a name. Um, Mariam, I want you to give me a name, a number. We'll make an alkene for that. Okay. So choose any one from all these. I want you to give me a number for the carbons, and then we'll make an alkene from it. 6. Okay, so hex. Okay, let's see. So we have to make 6 carbons. 1, 2, 3, 4, 5, 6. Now, I'm just making a general alkene over here right now, so I won't go into too much detail in naming that alkene for you guys. I'll just give a simple name for it. So for the double bond part, we can make the double bond anywhere over here. Okay, for example, if I make the double bond here, so this is one double bond, the rest should be single bonds of the carbon. Do we get this part? Like this. Then 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, and then 4. This is how it should look like. We'll just place the hydrogens over here now, like this. And what do we call this now? How many carbons do you guys see over here in this chain? 1, 2, 3, 4, 5, 6. Yeah, so it will be named hex, and we see a double bond here, so it belongs to the family of alkene and not alkane. So it won't be hexane, it will be hexene. Got it? Easy? Okay. So you'll have to properly memorize all these things. That's it. So let's go through the book now. See here. What is this? Is it an alkane or is it an alkene? This one. I want all of you all to answer and be a little quick in answering me, please. Oh, okay. 1 minute. Is it visible now? 1 minute, I'll share it again. So tell me, what is this CH4? Is it an alkane or is it an alkene? Alkane. Good. See this one. What is this? Ethane. Okay. See this propane over here. How many carbons should be there in this one? Propane. 3 carbon atoms. Here you go. You can see over here 3 carbon atoms. This is how you make the structure. This is how you write the general formula for it. Have a look here now. Butane, pentane, hexane. Digest this properly. Have a look at this. All of them are displayed on your screens. Okay, and do not forget this saturated hydrocarbons and unsaturated hydrocarbons part. Okay, no questions. Should we move on? Okay, I've already told you all about this whole thing. Here we go. For our alkenes now. See here. See these two things? These are our carbons. They are making these two double bonds over here. Look, from where is it starting? Ethene, propene, butene. And like for example, have a look at this butene over here, or no, have a look at propene over here. I'll make another propene for you. See, carbon, carbon, carbon. Propene must have 3 carbons. I'm making the double bond over here. They have made it on the right, I'm making it on the left. So according to this, how would my whole structure look like? 1 2 3 4, 1 2 3 4, 1 2 3 4. All right, okay. So how do I make the hydrogens now? 1 2 3 4 5 6. Let's see, is it fulfilling the the general formula for alkenes or not? The general formula for alkenes was CnH2n. How many carbons do we have? 3 carbons. So let's write 3 in place of n. Then H2, again 3 in place of n. What does this give me? C3H2 threes are 6. C3H6. Do I have 6 hydrogens in propene? 1, 2, 3, 4, 5, 6. Yes. So do not forget this. Now, okay, have a look here. Look at this structure and look at this structure. Both of them are correct. Okay, do not get confused anywhere. If I make a structure like this and I ask you that which one is propene, both of them are propenes. Got it? Okay. Have a look here. In the same way for butene, I can make this single bond, I can make the double bond here. Then I'll just adjust the hydrogens accordingly to that part. In the same way, so in the same way, I can place my double bond here as well. Then this will be my single bond. I'll adjust the hydrogens accordingly. Then I should not have more than 4 uh, bonds with the carbon. Do not forget this. Okay. So I guess all of you now understand what are alkanes and alkenes. Yes or no? Okay. Now I'm giving you all an exercise. I'll give you all a name. I want you all to draw it for me and send me the pictures separately in private. Okay. This is what we'll do for today. That's it. Tomorrow I'll start off with the rest of the organic chemistry with you guys. Okay.